Hi everyone, in this video we are going to talk about rational equations. Let me turn off my notifications here. Okay, so we're going to talk about rational equations. So one thing I want to talk about before we get into any of these is we have to remember a little something about excluded values. Okay, and excluded values, at least in the context of rational equations, are any number. It would be any number that makes the denominator equal to 0 for how the equation is initially expressed. So when you solve an equation, if you get back some number that would have made the denominator equal to 0, so we'll say any solution makes the denominator equal to 0. And remember, the reason we can't do this is because we can't divide by 0. Okay, so in this first example here, we have 4 is equal to 3 over x minus 3. So the idea here is if we were to get back, I don't know what the solution here is quite yet, but if we were to get back that 3 was the solution, we would have 3 minus 3 in the denominator, and we can't have that because we can't divide by 0. Okay, so that we would consider that an excluded value, and if that were the case, we would say this first one has no solution. But let's go ahead and jump into it and get started here. So that's something to remember. So you always want to check. So before we even get started with any problem, we need to first establish what the excluded values are. So let's go ahead and do that. So this first one here, we have 4 equals 3 over x minus 3. So we'll say excluded values. Okay, this is anything that would make the denominator of any rational expression in this equation equal to 0. So if we had x equals 3, then we'd have 3 minus 3 here in the denominator, and we would have that equal to 0. So we have one excluded value, which is 3. So now we can go ahead and solve the equation. So the goal here is to isolate x all by itself. So we need to get x out of the denominator. Okay, so to do this, let's go ahead and multiply both sides of the equation by x minus 3. Okay, so the x minus 3's here will cancel, and we're left with x minus 3 times 4 is equal to 3. Okay, and now we can distribute this 4. So we have 4x minus 12 is equal to 3. So now we can add 12 to both sides. And we get 4x is equal to 15. And now we can go ahead and divide both sides by 4. Okay, so we get x is equal to 15 over 4. Okay, so there we go. X is equal to 15 over 4. All right, so now let's look at 8 is equal to negative 1 over u plus 7. So very similar to last time. Let's go ahead and multiply both sides by u plus 7. The u plus 7's here will... Oh, I'm sorry. We need to back up. It's very easy to forget this. Excluded values here. Excluded... Okay, we have u plus 7 in the denominator here, so that means that negative 7 is going to be off limits because negative 7 plus 7 is 0, and we can't divide by 0. Okay, so now we're good. So now we have u plus 7 times 8 is equal to negative 1. So if we distribute the 8 here, we will get that 8u plus 56 is equal to negative 1. Okay, and now if we take 56 away from both sides, we'll have 8u is equal to negative 57. We can divide both sides by 8, and we get u is equal to negative 57 over 8. I think that's as much as you can simplify that. And that's not our excluded value, so we are good. Okay, how about this one? Here we have 4 plus 3 over u minus 2 is equal to 7 over u minus 2. Okay, as always, let's go ahead and find our excluded values. Okay, so in both cases here, we have u minus 2 and u minus 2 in the denominator, so it's the same thing in both cases. So we really only have to worry about just one, which is u minus 2. And so if we let u equal 2, we have 2 minus 2 is equal to 0, and we have u equals 2 is an excluded value. So if we get 2 back at the end, we know we can't have that. So, okay, so now let's go ahead and multiply. Well, not quite yet. Let's notice something here. We have 4 plus 3 over u minus 2 equals 7 over u minus 2. So we can actually go ahead and simplify this. Since both 3 over u minus 2 and 7 over u minus 2 have the same denominator, we can combine these into one fraction. So we can take 3 over u minus 2 away from both sides. Okay? So if we do that, then this will go away. And we have 4 is equal to 7 minus 3 over u minus 2. Or 7 minus 3 is equal to 4. So we have 4 is equal to 4 over u minus 2. So now we can multiply both sides by u minus 2. The u minus 2's will cancel, and we're left with u minus 2 times 4 is equal to 4. Okay, and you can distribute the 4, or you can divide both sides by 4, since this will divide nicely. I'm going to do that. We can divide both sides by 4. Then these will cancel, and so we're left with u minus 2 is equal to 1. So now we can add 2 to both sides, and we get that u is equal to 3. So u equals 3 is not one of our excluded values. Our only excluded value is u equals 2, so we are good to go with u equals 3. Okay, how about 3w over w plus 6 minus 4 equals 7w over w plus 6? Okay, well, let's go ahead and we'll notice again that these have the same denominators here. So we only have to worry about the one excluded value, okay? So our excluded value is whatever would make w plus 6 equal to 0. Okay, and so negative 6 would do that. So negative 6 is our excluded value. So if we end up with negative 6, we have a problem. Okay, so here we go. Now we notice that, again, because they have the same denominator, we can combine 7w over w plus 6 and 3w over w plus 6 into one fraction. So if we take 3w over w plus 6 away from both sides, these will cancel, and we have negative 4 is equal to 7w minus 3w over w plus 6. Okay? And that gives us that negative 4 is equal to 4w over w plus 6. Okay? So from here, we can go ahead and multiply both sides of the equation by w plus 6, because we have to get the variable out of the denominator. So we'll multiply both sides of the equation by w plus 6. Okay? And that's going to give us, if we go ahead and cancel here, we can distribute. So we're going to get negative 4w minus 24 is equal to 4w. Okay, so let's go ahead and add 4w to both sides. Okay, and we're going to end up with negative 24 is equal to 8w. And from here, we can divide both sides by 8. And that's going to give us w is equal to negative 24 over 8. But that simplifies just to negative 3. And remember, our excluded value is negative 6. So we are good. Hopefully we'll get one that has an excluded value eventually. I didn't select for that, but you're not often going to get those, but it does happen from time to time. So you do need to be mindful of your excluded values always. Even if you never end up needing to use it, it's important to be mindful that these are excluded values. Okay, next we have 1 over y plus 5 minus 3 over y minus 2 is equal to 7 over y squared plus 3y minus 10. Now, before you find excluded values, I do recommend trying to factor everything as much as you can, and I think we can factor y squared plus 3y minus 10, so let's go ahead and do that. So if we factor y squared plus 3y minus 10, we can rewrite this whole thing as 1 over y plus 5 minus 3 over y minus 2 is equal to 7 over, and this is the factoring part here. We need to find two numbers that multiply together to give us negative 10 and add together to give us 3. And I think 5 and negative 2 should do the trick. So if you take 5 times negative 2, you get negative 10, and 5 plus negative 2 gives you 3. So we can rewrite this as y plus 5 times y minus 2. Okay, and if you don't believe me, FOIL this back out and you should get y squared plus 3y minus 10. And what's really nice here is that these have the same factors, at least in the denominator. So this should make simplifying it easier, and it also makes our excluded values a little easier. So let's go back up to the top here and do our excluded values. Okay, so now we have multiple things to consider. So we have y plus 5, y minus 2, and y plus 5 times y minus 2. Okay? But what's really nice here is that if either y plus 5 or y minus 2 in the denominator on the right-hand side is equal to 0, the whole thing is equal to 0. So we really only have to consider y plus 5 and y minus 2. So if we have y plus 5, negative 5 would do the trick. So negative 5 plus 5 is 0. And for y minus 2, 2 would do the trick, right? So 2 minus 2. So if we end up with a solution here of y equals negative 5 or y equals 2, we know that we have to exclude it from our solution. And now let's see if we can solve this. So what we need to do now is we need to go ahead and see if we can find a least common denominator here. Okay, so in order to do that, what we're going to do is we're going to, in a clever way, multiply both 1 over y plus 5 and 3 over y minus 2. We're going to multiply them by 1 in a clever way. Okay, so to do this, if you notice, if we want to find a least common denominator, we can multiply 1 over y plus 5 by y minus 2 over y minus 2. That's equal to 1, so it doesn't change anything. So let's write that. So if we have, this will become 1 times y minus 2 over y plus 5 times y minus 2. And again, hopefully you'll see that doesn't change anything, because if you cancel y minus 2 over y minus 2, we just get 1 over y plus 5 back. Okay, and then 3 over y minus 2, we can multiply by y plus 5 over y plus 5. So we have 3 times y plus 5 over y minus 2 times y plus 5. And what you'll see here is that now all of these have the exact same denominator. Okay, so we have y plus 5. For this one, we have the same, all three of these now have the same denominator, right? So y plus 5 times y minus 2 is in the denominator for all of these. And so now we have the luxury of being able to combine all of these into one fraction. Okay, and we're going to do this in one step here. So we can add 3 times y plus 5 over y minus 2 times y plus 5. And we're going to take away 1. We can just ignore the 1. So we have y minus 2 over y plus 5 times y minus 2. And we're going to take these each away on both sides. So we'll have minus y minus 2 over y plus 5 times y minus 2 plus 3 times y plus 5 over y plus 5 times y minus 2. Okay, my pencil's kind of acting up here, but yeah, that's sort of the idea here. Okay, so this will cancel, so we're good there. And we're gonna move this down, so we need more space. Okay, and so now what we have left is we have, we can combine all of these here on the right-hand side into one fraction. So we're gonna end up with 7 minus y minus 2 plus 3 times y plus 5 all over y plus 5 times y minus 2 is equal to 0. Okay, cool. So now we can, looks like we can, let's see what we can do here. Okay, so in this case, let's go ahead and see if we can simplify the numerator. Okay, so we can have 7 minus y, and if we're distributing this negative here, this will become minus y plus 2. And if we distribute the 3 to the y and the 5, we get plus 3y plus 15 all over y plus 5 minus, or times y minus 2. Okay, this is equal to 0. Now, if we combine like terms, we have negative y plus 3y. That's going to give us 2y. And then 7 plus 15, it gives us plus 21. Plus 22. 2y plus 22 over y plus 5 times y minus 2. Okay, now something to note here. So this is equal to 0. Okay, so something to note here. This is a little tricky, I must confess. So one thing we need to think about here is you can actually sort of, in a way, ignore the denominator. Okay, and why can we ignore the denominator? The reason we can ignore the denominator is if the numerator is equal to 0, well, obviously the whole thing is going to be equal to 0. So really all we have to consider is when the numerator is equal to 0. So here we have 2y plus 22 is equal to 0. So if we take 22 away from both sides, we get 2y is equal to negative 22. If we divide both sides by 2, we get y equals negative 11. Okay? And I must say that was not one of our excluded values, so y equals 11 is completely and totally permissible. Okay. So now let's go on to another one. Move this way down. Okay. Alrighty, so very similar here at the last time. We need to figure out excluded values. We also should go ahead and factor this u squared minus 9 over here in the denominator. So let's rewrite this. So we have 1 over u minus 3 plus 4 over u plus 3. And this is equal to 1 over something that we're going to factor. So what you'll notice here is that u squared minus 9 is a difference of squares, okay? And remember, I'm probably getting tired of hearing this, but if we have a squared minus b squared, this is equal to a plus b times a minus b. Okay, so the square root of u squared is u, and the square root of 9 is 3. So we can write this as u plus 3 times u minus 3. And this is very similar to what we had in our previous example. Okay, so now we can go ahead and do our cross multiplication here. All right, so I'm going to show you another way to do this. Another way we can do this is we can multiply both sides of the equation by u plus 3 times u minus 3. So what we did last time was we multiplied both 1 over y plus 5 and 3 over y minus 2 by this denominator and this denominator over itself. What we're going to do here now instead, I'm going to try a different method here, is we're going to multiply both sides of the equation by this denominator here, okay, over, yeah. So what that's going to do is it's going to allow us to cancel what's in the denominators over here, okay? So let's go ahead and multiply by u plus 3 times u minus 3, okay? Let's move this because we need a little more space here. Okay, so now we're going to do u plus 3 times u minus 3. Okay, and that's going to allow us to cancel here. Okay, these will all cancel. So now we're going to be left with, on the left-hand side here, we can distribute this whole thing, u plus 3 times u minus 3, to each of these. So we'll have u plus 3 times u minus 3 over u minus 3 plus 4 times u plus 3 times u minus 3 over u plus 3, and this is equal to 1. Okay, and you may find this method to be easier. You may find the previous method to be easier, but they're both totally acceptable ways to approach the problem. Okay, so let's go ahead and do some simplification. Oh, and I almost forgot. We need our excluded values. Let's go back to the beginning. Okay, our excluded values. So we had factored this to u plus 3 and u minus 3 on this turned into u plus 3 times 2u minus 3. So we really only need to consider u plus 3 and u minus 3. So our excluded values are going to be 3 and negative 3. Okay, so if we end up with either of those, we'll know we have a problem. Okay, so now we can do some canceling. We have u minus 3 and u minus 3. That'll cancel here. And here we have u plus 3 and u plus 3. So this is going to give us u plus 3 plus, since the denominator is simplified to 1, we actually don't even have a rational expression anymore, plus 4 times u minus 3 is equal to 1. Okay, now let's simplify. We can do that by distributing this 4, and that's going to give us u plus 3 plus 4u minus 12 is equal to 1. And now we can combine like terms, and in doing that, we're going to get 5u minus 9 is equal to 1. So we can add 9 to both sides, and we get 5u is equal to 10. So we can divide both sides by 5, and we get u is equal to 10 over 5, which is 2. And our two excluded values were 3 and negative 3, so u equals 2 is fine. Okay, let's do one more. Okay, so here we have 6 over u squared plus 6u plus 8 equals 1 over u plus 4 minus 3 over u plus 2. So let's see if we can factor the left-hand side denominator, and then we can find our excluded values, and we should be good from there. Okay, so here on the left-hand side, we have u squared plus 6u plus 8. So we want to find two numbers that multiply together to give us 8 and add together to give us 6. And if you can pick the pattern up from what we're doing so far, it's probably going to be u plus 4 and u plus 2. And it is. So we'll have 2 and 4. 2 times 4 gives us 8, and 2 plus 4 gives us 6. So we can rewrite this as 6 over u plus 4 times u plus 2 is equal to 1 over u plus 4 minus 3 over u plus 2. Okay, and now let's find our excluded values. Okay, so we have u plus 4 times u plus 2, and then we have u plus 4 and u plus 2 for our denominators. So we only have to worry about u plus 4 and u plus 2. So negative 4 and negative 2 are going to be our two excluded values. Maybe we'll get one this time. If not, I'll make sure to post an example with one that has an excluded value so you see what that looks like. Nothing really changes other than you just say that can't be a solution. And if it's your only solution, then you're done, right? So Yeah. All right, so let's go ahead and see what we get here, right? So, so we can let's do the method we done the last problem. Let's go ahead and multiply both sides by u plus 4 times u minus 2. Okay. U plus 2, not u minus 2. U plus 2. Okay. All right, so this will cancel, and that's going to give us 6 is equal to. Now we can go ahead and multiply. You can distribute this here, okay? So that's going to give us u plus 4 times u plus 2 over u plus 4 minus 3 times u plus 4 times u plus 2 over u plus 2. Okay. So let's cancel the u plus 4s, and we have u plus 2 here. So we're left with 6 is equal to u plus 2 minus 3 times u plus 4. All right. And then that's going to give us 6 is equal to u plus 2 minus 3u minus 12. Okay, cool. So now if we combine like terms, we get 6 is equal to, with u minus 3u, that's minus 2u, and 2 minus 12 is minus 10. Okay, so if we add 10 to both sides, we're going to get 16 is equal to negative 2u. And if we divide both sides by negative 2, we get u is equal to negative 16 over 2, or we get negative 8. Okay, so stay tuned for part 2 of this one. There's a few more examples that I would like to do. So we're going to have this in 2 parts.